Well, thanks for the opportunity to come and speak with you guys. So who are you? Are you undergrads? Okay.
And grads.
And grads?
Yeah.
And where do you hail from? Are you atmospheric science? Are you?
They're kind of all over the place.
Okay.
Because the undergrads are doing the climate science minor, most of them, not all of them, some of them. And the graduate students are also from all over the place. Some of them are doing the graduate certificate.
Got it.
So
Okay.
from policy through to oceanography, atmospheric sciences. So it covers it.
Okay, great.
But they're all at least seniors, undergrads.
Okay.
So they're not freshmen, right? Any freshmen here? No. Okay.
And have any of you, have I talked in any of your classes before? Okay. So you won't be too bored. Let me get everything set up here. Well, I'm glad to be able to come and speak with you. I'm not wearing a mask mostly because I think it's easier to teach and for you to hear me when I'm not wearing a mask. And also I'm about as protected as they get. And from my point of view in my world, this is a pretty low risk situation, but happy to talk about those considerations if you'd like, because we've been swimming in this sea of questions about COVID for 2 years. So happy to discuss. And also happy at any point, if you have questions about anything, just pop up a hand and I'm more than happy to deviate from the slides I prepared. In fact, I prefer to have discussions, not speak at you. So as Lynn said, I'm trained as a physician primarily. I practice emergency medicine. I'm also trained in environmental health. And I do a lot of different things related to climate change and health. And what that means probably isn't obvious to you. Hopefully will be more so after I go through my talk. I am not a climate scientist. I don't even pretend to be. I just pretend to understand how climate scientists do their work well enough to incorporate it into my work as a piece of exposure, which drives health impacts and thinking about preparedness in the health sector. And I was a lead author on the 6th assessment report. So you know, as you go through the course, there are people who coordinate the whole thing. I was not one of those. And then there are people who coordinate chapters. Those are called coordinating lead authors. And you'll hear from one of ours, actually, Robert McClellan, later in the course, in the quarter. And then there are lead authors who kind of are workhorses on the chapter. And then there are some contributing authors who write little bits and pieces that get inserted. So I was a lead author on the health and changing structure of communities, health, well-being and changing structure of communities chapter for the 6th assessment report. I also was a lead author on the special report, the SREX, special report on extreme events and disasters to something climate change adaptation. IPCC loves really contorted titles and contorted figures, as you'll see. But basically, 2 reports, one on disasters and one on the big assessment reports. And that was just released, as you know, if you've read the Summary for Policymakers. It's the only part of the report that's actually formatted. The rest of it, as you'll see in my talk, there are some unformatted pieces. And then there's Working Group 1. Are you assigning that report to them too? Okay. So how many of you know how the IPCC is organized? A couple. Okay. So there are 3 working groups. And the first one is mostly the atmospheric scientists, the physical scientists who talk about what's happening with the climate, what we can expect, go into great detail about emissions and warming and other environmental impacts and trajectories going forward. This working group 2 is impacts and adaptation. So what is actually happening as a result of the environmental changes, atmospheric and oceanic and other changes that are reported out by Working Group 1. Working Group 2 takes that up, says, okay, what does that mean for human society, for different sectors of the economy, et cetera? And what can we do about it? Adaptation. Adaptation being both anticipating adverse impacts and trying to address them, lessen them and address them, and also thinking actually about possible beneficial impacts of climate change and taking advantage of those as appropriate. Then the third group is, Working Group 3 is focused on mitigation and the potential for preventing all of this. And sometimes the groups work together. So on that disasters report I referred to, Working Group 1 and Working Group 2, it's the first time they came together and did a report together and worked closely. Otherwise, a lot of the times the groups are fairly siloed. And so for Working Group 2, you get a lot of impact scientists and a lot of adaptation scientists, but they don't spend a lot of time talking with the atmospheric scientists. The atmospheric science work usually comes out first, and then the impacts and adaptation second, and then the mitigation third. And I don't know why that is. It seems like mitigation should come first, but there you have it. And the assessment reports of the IPCC are done on roughly a 6 to 7 year cycle, and they're very big efforts. They're global efforts to bring together the scientific community from all those different disciplines and assess all of the literature, usually, in the last 5 years. In this case, the cycle was extended by almost 2 years because of the pandemic. So this was a pretty Herculean effort, and a lot of us struggled, particularly in the health chapter, because most of the people in the health chapter are health people, and it was not a good 2 years for us in the health sector. But overall, I think it came together reasonably well. So let's see how we advance slides on this. So what I'm going to do is I'm going to start actually with the updates about climate change from Working Group 1, which just sets the stage. And again, I am not a climate scientist. I will happily yield the floor to my climate science and oceanography friends and colleagues to explain things and answer questions you have. But I do think it's important context for the findings presented in Working Group 2. And then I'm going to talk to you a little bit about climate change and health and what in the world we're talking about, why it's an issue, and how we think about it. And then I'll take you into the second Working Group report of the AR6 and our chapter specifically, and then we'll have time for questions and discussion. So I'm going to acknowledge, as I pretty routinely do now, it's not exactly a trigger warning, but acknowledge that some of this material is anxiety provoking, and it's anxiety provoking for me. I've been doing this for a long time. And when I first delved into it, I think I got a little depressed for about 6 to 9 months. But then I got past that is probably too strong, but through that, mostly by thinking about ways to move forward. And so I like to, when I talk about this work, say that I'm going to talk about the problems, and some of them are big problems, and they're anxiety-provoking problems because they feel overwhelming, and I get that. And I'm not going to shy away from talking about the problem. I think some people don't. They say, well, we don't want you to talk about the problem. We just want you to talk about solutions. I actually don't think that that's really appropriate, partially because I'm a doctor, and when there are problems, I feel obliged to tell my patients about what's going on and the prognosis. But I always try to focus on solutions and think about, what the next steps are. So the primary goal isn't to tell you about the problem and stop there. It's to talk about the problem so you understand it and then move forward to figure out what to do about it. And so for me, the goal is for you to understand the magnitude, the timing, the distribution, very importantly, of the risks, and to understand then about how that might feed into risk reduction. And I think it's important to try and be hopeful, even though being hopeless is perhaps a natural, albeit perhaps transient response to some of this information. being hopeful is actually part of getting through it and dealing with it. And a colleague of ours named Howie Frumkin, who some of you may have met or heard speak, also a physician, an environmental health practitioner, former dean of our School of Public Health, and a friend, just wrote a good paper about this. He wrote a paper about hopefulness and hopelessness from a medical perspective, but specifically related to climate and health. And quoting another scientist in his paper, hope is the perceived capacity, or excuse me, capability to derive pathways to desired goals, motivate oneself via agency thinking to use these pathways. So what I take away from this is hope is an internal state, a perception of capability to head in a certain direction. So you've got pathway thinking and you've got goals. And then there's this important issue about agency, which is when you read agency, what do you hear? What does it mean to have agency?
Organization.
Foundation?
Organization.
Oh, organization. Yeah. Okay. So agency, you come together and you have a way of working together institutionally and individually to accomplish something. Sure. What else? So a sense of control that in fact, if you do something, it will matter. Okay. What else? Ooh.
Taking initiative.
Thank you. Taking initiative. Okay. So motivation and initiative. Yeah, all of those things are really important. I think this is actually when you unpack this definition, this is an important thing to sit down with, this question of agency, because part of the problem is this is a collective action problem, right? Everybody at some level, we feel like, well, I can't do enough on my own to fix this. Therefore, I'm at some level disinclined to make some of the changes that might be required. I don't feel like I have agency to make a difference. But I think there are actually a lot of things about these problems that you do have quite a bit of agency individually and collectively to address, but as individuals, as UW students and members of the UW community, and in your professional lives going forward. And from my point of view, for my work, my goal here is health protection, and my pathway is an evidence-based public health practice. And then my agency comes from my own experience, my knowledge, my perspective, my experience working in organizations, and the skills that I may bring to a given situation to move things forward. But I think other people have different sources of agency around this problem, and that's great. So hopefully that is a constructive way to think about some of the anxiety that some of this might provoke for you. So what does Working Group 1 tell us? How many have read the Working Group 1 summary for policymakers? Okay. Not that many. I would encourage you to take a look at it. It's not that long a read, and I'm mostly going to present the graphics from it, which, as I said, in true IPCC fashion, they're great if you sit and stare at them for about half an hour each, but I'm going to try and walk you through them. This one's pretty straightforward. The world is warming, and this is the simulated climate without anthropogenic or human forcing, and this is what we're seeing. And we clearly have departed a pathway where there's any question that humans are influencing the climate, which I know you may think is kind of quaint and a foregone conclusion, but in fact was a matter of real scientific debate within just the last 2 decades, maybe a little longer than that, depends on who you were. But there was a lot of fighting about this. And you can see here that the 2 paths, really the cones of certainty, really diverged right around 2000. Now we're very clearly, unequivocally affecting the Earth's climate. And that message has come through in the past several reports of the IPCC. But it nevertheless bears mention. So what can we expect going forward? I hope you can see that in the back of the room. Basically, to walk you through this, these are scenarios. So these are emission scenarios. These numbers here, 1.9, 2.6, 4.57, and 8.5. And they're designated that way based on the amount of warming at the end of the century that watts per meter squared of that each of these scenarios denotes. And so 8.5 is the most dire scenario where we have the most warming. These SSPs are shared socioeconomic pathways. And you're going to be hearing from Chris Ebi next week, right? Or sometime soon, who helped develop these. And these are not emission scenarios, but socioeconomic scenarios. And they interact with one another. In a high emissions world, you're locked into a certain sort of set of behavior patterns globally that are captured in SSP5. So this column is what can we expect between 2021 and 2040. And basically, they don't really, in the near term, diverge that much. So between 2021 and 2040, our best estimate is we'll have 1.5 to 1.6 degrees of warming, global average surface warming. The likely range does diverge a little bit. And when you're at a high emission scenario, the very likely range, a little bit of the uncertainty, is warmer than a lower emissions range. But remember, this is now, right? This is effectively now, because it includes now. Midterm is 2041 to 2060. So 19 years from now, at least, best estimate, low emission scenario, 1.6 degrees of warming, up to maybe 2. High emission scenario, best estimate, 2.5 degrees of warming total, and up to 3. Wow. We are just over 1 degree now. By the end of the century, this is long term, by 2080, so you guys will be finishing up your careers. We'll probably be dead of a heat wave. Best estimate with a low emission scenario, 1.4 degrees. Best estimate of a high emission scenario, 4.4 degrees. With, again, a range between 1, very low end, and 5.7 at a very high end. So those are numbers, yeah.
What's the baseline for the temperature? Is it like the temperature that it was in 2000, or is it the predicted without?
It's pre-industrial. This is all reference to pre-industrial.
Which is like 1850.
Yeah. So around then we were about a degree cooler, or globally the world was about a degree cooler. And you should note that this is average surface temperature, and the Earth is mostly covered with water. Land masses warm faster. So 1 degree warmer or cooler back then was average. So different over land, a larger difference over land. And there was something else I was going to say about that, but yeah. Any other questions about this? Okay. So those are all numbers, and some people think in numbers, and that's great, but a lot of people don't. And pictures are helpful, I think, to start capturing what some of this means, because what it essentially means, you know, you're adding energy to the climate system, and that energy is passed on to all sorts of systems globally. And when you think about it, it means that certain events are more likely. So historically, these 10-year heat events, so an event that would have come around once every 10 years. Now we're seeing those events about 3 times more frequently than we did. And going forward with 1.5 degrees of warming, which we're going to probably blow by in about 7-8 years is my guess. I don't know what you all think, but that's my hunch. About 4 times as likely. 2 degrees of Celsius, 2 degrees 5.5 times, 4 degrees of Celsius, 4 degrees of warming, 9.4 times more often. You'll see these 10-year events. 50-year events, again, baseline once, present about 5 times more likely, etc. This has to do with differences in the way the distribution has shifted, that we are now much more likely to see certain extremes than we were going back in time. And the event that do you all actually know the return period for the heat event we had here in 2021? That heat event that we had here, maybe this isn't a good illustration, but it was unprecedented. So we don't really have a return period for that event. But it's a good example that we are now leapfrogging these probabilities and seeing these events much more commonly than we used to. And the same goes for precipitation and drought. So changes in the water cycle from climate change mean that we're now seeing more heavy precipitation events 1.3 times. So it's not the same multiplier. And with 4 degrees of warming, about 3 times more of those events. And same with drought. We're now seeing an event that would occur once every 10 years is now occurring twice every 10 years. And so forth up through different levels of warming. Sea level rise is also, we're getting more and more clarity about exactly how much sea level rise we can expect. There used to be a very wide range that was reported out, and it's narrowing. And you can see that generally with different emission scenarios, we're probably somewhere between 0.5 meter and 1 meter of sea level rise by the end of the century. But under a really high emission scenario, we still could see quite a bit more than that. And I don't know if you have anything you want to add to that.
Well, just the unlikely event is if the big ice sheets start to melt in earnest. So Greenland and Antarctica. In particular, Greenland is probably the first because it's more impacted by ocean and at lower latitudes than Antarctica. Is that what you want to comment on?
Yeah, whatever you wanted to say.
Yeah, so it's kind of, we're thinking in some sense it's less likely than we thought originally, but it's still very clear that particularly Greenland is melting much faster than it was.
That's been kind of a theme of at least my experience with climate change estimation, that we've always been sort of at the high, as I've gone through things, the next round of observations are at the high end of what we expected in many cases. Things are happening faster and in some cases are worse than we thought they would be with our central estimates, unfortunately. But I do think, it used to be the confidence intervals that I would hear people talking about were up to 2 meters, and now they seem to be closer to 1 for most things.
So most of the sea level rise that is in here is coming from things like glaciers and the Cascades melting and warming of the ocean, because when water warms, it expands.
It gets bigger. Yeah.
So that's enough.
And I will say, when we think about impacts, sea level rise is one of the things it's a little bit hard for us, a lot of other things, at least in health, we sort of have some historical experience with somewhere that we can say, okay, well, this gives us some sense of how a system might respond to this stress, heat wave, fire, whatever it might be. Sea level rise is a kind of a different beast because we've never had sea level rise globally at this rate and of this magnitude before. So it's very difficult to know exactly how it will affect human society, though I think we can all be confident that it'll be a big stressor. I included this, again, it's a little bit of a penetrating glimpse into the obvious, that every marginal bit of emissions adds to the warming. I think this is actually really important for us to understand, particularly because we live in a very high emission society where we do things like fly across the country several times a year, many of us, because we feel like we have to go see our families. And that's debatable, but it also means that those emissions are just as real as emissions somewhere else that you might want someone to curtail. And we have to get more realistic about this in our discussions, starting here at the university, recognizing that, these emissions matter and every single additional ton matters. Which leads us to another figure from Working Group 1, which is about carbon budgets, which is interesting because they don't really normally talk a lot about carbon budgets, usually more of a Working Group 3 thing. But one of the things that has happened with these reports, there's been more of a recognition of the need for interdigitation across these different groups and combined messaging and other things. And so we emitted last year, anybody know how much we emitted globally? Pandemic year, remember? We were hoping emissions would go down substantially. We emitted about 38 gigatons of carbon. That's 38 billion tons of carbon. Total historical emissions are about 2,400 gigatons. The United States is the leading historical emitter. We're the second leading current emitter after China. If we wanted to keep warming to 1.5, which is another 0.43 degrees of warming, and we wanted an 83% likelihood of achieving that, we could continue emitting at the current rate for about 7 more years globally. Got it? It's not going to happen. We are not going to stop at 1.5. We may eventually get there, but we're not going to stop. To get to 2 degrees and keep ourselves below 2 degrees with an 83% probability, we can only emit 900. So another 25 years maybe of current emissions before we have to curtail all of it. So obviously a really steep drop off. The point here is not to say we can't do these things, but to make it clear what the challenge is and that we need to be realistic about the likelihood of what is coming and the impacts and some of the risk management potential, including geoengineering of a different sort, which sadly I think this report doesn't engage around, which is too bad because I think it's actually a reasonably likely event if it hasn't happened already. So this is controversial and people have lots of different opinions about it.
I assume that will be in Working Group 3.
I don't know. I don't think that there was, I didn't look at the table of contents. So I have no idea. Interestingly, I mean, it was not at all discussed. The impact of geoengineering would have been Working Group 2, and that was not really discussed at all. So it used to be, I would say 10 years ago even, that was completely off limits as a discussion. And now there's a lot of scientific effort going into thinking about it. But I think that the governance of that is lagging quite a bit. So before I move into climate and health, any questions about anything I've presented so far?
Is this all familiar to you, or have you seen various aspects of this, probably in courses and stuff? Maybe not as up to date as this.
Is this recorded?
Yeah, we're trying to record it. It won't be as good as being here in person.
I don't know how good the audio will be, but
I just posted the working group report on the 586 site, and I'm about to on 475.
Okay, so why is this a health issue? In some ways it's obvious, and in other ways it's not. This is a slide from CDC, and in the center of it, you see these environmental impacts of climate change. Sea level rise, we didn't talk about ocean acidification, but that's part of it too. More extreme storms, more warming, obviously. And those are the exposures that we worry about. And some of them have very direct, immediate impacts on people's health. So when it's hot and people are exposed to that heat, if it's a dangerous level of heat, particularly if they're not acclimatized to it, then they can get heat illness. Or if they have chronic diseases, heart disease, kidney disease, et cetera, it can stress their body systems so that they don't necessarily get heat illness, but they come in with a heart attack that they wouldn't have otherwise had, or trouble breathing that they might not have had, et cetera. So there are some direct pathways. Same thing with extreme storms. There's a lot of energy in those storms, wind energy and other things, and people get injured during those events. So there are some causal pathways that are really short and direct between the energy in climate change and that energy is in some way visited upon people's bodies and they're injured and have adverse health effects. But then there's a whole bunch of other causal pathways that are kind of intermediate length. So air pollution. So some of you probably are not familiar with how air pollution works, but we have emissions from fossil fuel combustion. So we drive cars that run on diesel and gas, or we burn natural gas to heat our buildings, and that emits particles and nitrous oxide and some other things that then in the presence of heat and light convert into other more dangerous chemicals. So if you increase warming, you increase the formation of air pollution, all things being equal, if you have those precursor pollutants. And all of that air pollution, worse, it causes cardiovascular disease, it causes cancer, it worsens asthma. So you get there's this intermediate pathway where warming drives these other exposures that are bad for health. And then you see things like increasing air allergens. So here, this is an ecologically mediated pathway where warming and to some degree precipitation and carbon dioxide fertilization of plants leads to earlier flowering, earlier pollen emissions. In some cases, and we don't entirely understand why, the pollen is more allergenic. And so people have more allergy symptoms. And that doesn't sound bad unless you're a bad allergy sufferer, in which case it's pretty miserable, or your kid's a bad allergy sufferer and they're out of school a lot. It's actually a very expensive class of diseases. And you can kind of go around this diagram and find pathways that are climate sensitive in almost all cases. And about a little over somewhere between 50 and 75% of human disease burden is climate sensitive. It's not all equally climate sensitive, but it has some climate sensitivity. Then there are the long pathways. So things like environmental degradation and increasingly scarce freshwater resources, other things leading to migration and conflict. And that was part of what our chapter was about. And these are, again, I think kind of wild card questions. One, because we don't have historical experience with some of these things. And two, because they depend a lot on how we respond. So these are, some of these things just happen because when it gets warmer, they happen. But some of these things happen because when the world warms, it creates stresses that have to be dealt with politically. And sometimes we do a good job with that and sometimes we don't. And when you start mobilizing hundreds of millions of people who live in coastal regions and mix that with these other stresses, there's going to be some conflict as a result. I'll also say about mental health. Mental health is something that has increasingly been of concern related to climate change. partially because of what I talked about at the very beginning, that it makes people anxious and worried and scared about the future, but also because people with mental health issues, pre-existing mental health issues, whether it's a mood disorder like depression or anxiety, or it's something like a psychiatric disorder like schizophrenia, they're at increased risk of adverse impacts during extreme heat and other things. When they're displaced, they often have trouble recognizing dangerous exposures in the environment and responding to them, and they don't have agency to respond as effectively. And so there are a lot of, the mental health piece is complicated because it means different things to different people, but there's definitely a reason to worry about climate change and mental health impacts. Any questions about this? So in public health, we have learned in the last 50 years or so that healthcare, we used to think that, a lot of the variability in health status in a population was about healthcare access and what I do when I'm working clinically. And we've since learned that that's actually only about 10% of what drives a population's health status. Really what drives a population's health status is all of this other stuff. How much money people make, the equality of opportunity, access to education, access to clean water, access to clean air, just working conditions, all of those things, which is a great insight. It's a little frustrating to us in public health because we really don't have much agency to actually affect a lot of that. But we can point out the importance of those drivers. And I bring this up because climate change will probably affect healthcare service accessibility in some cases, but a lot of times what it's going to affect is all this other stuff. And there's worry that that will drive health impacts. The health sector is not as good, I think, as some of the other sectors, like or as economists and sociologists at thinking some of that through. And so we kind of lag in building up evidence around it, but we try. And if you take those insights and you think about them in terms of what makes a society vulnerable, then, and we think about global goals around development, they're the Sustainable Development Goals. Anybody know about those? They're familiar to you a little bit. And so there's a lot of synergy between climate action and the goals we have, the Sustainable Development Goals. And I want to point something out that, climate and health is an equity issue. And we're very preoccupied appropriately about equity here at UW and in this country increasingly. But I don't think we don't think about equity or climate change as an equity issue, but it is fundamentally an equity issue. It's probably one of the biggest equity issues that we actually face globally. Because all the countries that have caused the problem are not the ones that are impacted. That, as I said, we have a large historical responsibility here, a natural debt from our carbon emissions, and most other high-income countries do. But we're relatively protected. That's not to say we're not going to be impacted adversely. I think we definitely will be adversely impacted in parts of the United States. But it's really equatorial countries that are going to be impacted. And they are not getting the resources that they should be getting from us to address this. And it's not for lack of trying sometimes. Biden just proposed a new budget that does substantially increase or would substantially increase payments to those countries for adaptation. But I think well, we'll see what happens with the budget. I can tell you what happened with the last budget in that regard. Let's see. So one of the other things that we talked about is the different, the changes in disease ecology. And you can see here, this is a map of the hardiness zones for plants in the United States. And it's an old graphic. I wish they would update it because I'm sure it's probably jumped up since then, but I haven't been able to find an updated one. But it shows that pretty quickly between 1990 and 2015, you had these significant shifts in plant ecology in the United States, and it's changed more since then. The same thing is happening to all kinds of diseases, and we're seeing ecological changes all over the place. Some of them result in shifts in human disease, like Lyme disease, for instance. Lyme disease is very clearly moving west and north, and that pattern has actually been evident for about 10 years, and our government has not been comfortable naming it, but it's very clearly there. So I want to take you through a few other observed impacts. This is from the Lancet Countdown on Health and Climate Change. It's an annual report, unlike the IPCC reports that come out every 5 to 7 years. This is done every year, and it's a little narrower in scope, focuses on health, focuses on current impacts. And I'm part of the group that generates this. And we've noted that there's been actually quite a lot of work productivity due to excess heat in the last several years. There's also been a very clear increase in heat-related mortality globally, and that's attributable to climate change. One of the things that's new in our world scientifically is the ability to start attributing these impacts to climate change, which was really not easily possible at the last assessment report, but now is. And we're also seeing increases, of course, in heat waves, as discussed, also in wildfires. We're seeing a global increase in wildfires and wildfire smoke emissions. We're seeing declines in staple crop yields, maize, wheat, and rice, and soy. We're, of course, seeing increases in global disasters for climate-sensitive disasters. So earthquakes, which probably is our main hazard here, the thing we should be mostly worried about, they're pretty stable, but these other things that are drought-related or meteorological events are all increasing in frequency. And if you look at the United States and track health impacts here of climate-sensitive disease, I could tell you the story for almost all of these things. Each of them has an interesting story. But in 2004, there was a unprecedented outbreak of Vibrio parahemolyticus and Alaskan oysters. In 2009, dengue went from being a disease that had largely been eradicated in Florida to a disease that was now back. And now it's endemic, meaning epidemic means it spikes and then goes away. Now it's just there. It's just there. It didn't used to just be there, but it's now just there. We have no idea, because we don't survey for it, exactly how far north it's gone. But I mean, my hunch is if we did a seroprevalence survey, it would certainly have penetrated well into the southeast by now. We had an outbreak of valley fever, which is a fungal disease that used to really only be in northern Mexico, and then it was in Arizona and California, and now it's all the way up here in Washington. That was in 2010. Dengue in 2013 captured further north in Florida. Lyme disease, as mentioned, moving westward, and really now it's Canada's problem, moving northward. We've had terrible wildfires out here in the West almost every summer since roughly 2015. We've had devastating flooding in 2017 in Texas and 2019 in the Midwest. And I could go on and on and on, and will go on and on and on going forward because it's getting worse. So that's why we need to worry about climate change from a health standpoint. Yeah.
There's a good chance of us getting that we had last year.
Like getting it again, like having another event like that. I think we certainly will see warming, or we'll see a heat event like that again. I don't really know. I think that took everybody by surprise. I mean, I haven't, I'm sure someone has worked out the probability of it occurring again, but I don't know what it is. Yeah.
So are hospitals like preparing for the spread of disease? Like now, I mean, did Canada ever have, I actually don't really know much about Lyme disease, but like, did they have medication for Lyme disease before, or now are they having to produce it and they don't really know what, like, you understand my question? Because I don't know how to say it.
Yeah,
Okay.
yeah. So great question. And the answer to it is a little complicated. So the yes and no. To some degree, health systems operate on kind of an all hazards basis. So like, you know, we know at any given day, we could have a mass casualty event from a bad car crash or series of car crashes in the Harborview Emergency Department. We could have a mass shooting. We could have an earthquake. And we kind of staff and build out a model to be able to respond to those things and to take care of all the usual stuff that we see, the urinary tract infections and whatever it might be, right? The lower level stuff that comes in all the time. We don't really take forecasts of heat and say, okay, well, it's going to be a little warmer today, so we better staff up for that. And Canada is not saying, well, we're seeing a little more Lyme disease, we better produce more doxycycline, the antibiotic to treat it. But if you have a gradual change over time, you can mostly accommodate that. It's the shocks that are harder. And this past 2 years has been a great example of a totally new disease without diagnostics, without therapeutics. It's been actually incredible to see the health system respond. It's unprecedented. I think probably it feels, some people it feels slow or inadequate, but it's been incredible to see. I mean, this, and to have a vaccine that's this effective, like unprecedented in human history. If only we took some other things as seriously as that, I think we could make some great progress. But it's still been a shock, right? Like we've lost 1 million people in the United States to it. And and then, yes, we drill for bad things. We're not really drilling for, so we've never drilled for a bad heat wave here. And we were kind of caught unawares by it from a health standpoint. I'm not going to stand up here and tell you that we did a good job of managing that event, particularly our public health colleagues, frankly. And we don't at all think about the combined events that are more likely. So a heat event in the context of a drought with a wildfire and power outage, they're happening in California now. We are not preparing for it here. I think we think that all these trees and stuff somehow won't go up in flames someday, potentially. I don't know why, but so those sorts of things, that worries me. We're not preparing in that sense for it. The slower stuff, I think, is easier. But the other caveat I'll bring is once you start seeing some migration from sea level rise or other issues, then it becomes very difficult. So I think, Seattle's a good example. The Puget Sound's a good example. We have struggled to absorb all the in-migration that we've had here. It's economic, it's not for other reasons, but migration's migration. People move to seek better opportunity and avoid harms that evolve around them. It's not just climate change, it's going to be other things too. And places can't deal with that movement very effectively. The places that lose people lose a tax base. Detroit gets hollowed out and it never recovers. And I worry that the same thing could happen to Florida and other parts of the United States. And then the places that absorb rapid increases in people also have stresses dealing with that. So, and housing prices go through the roof, et cetera. So it's complicated. It's a long answer to a short question. Yeah.
What was your experience in the emergency room last summer during?
It was really hot. And I was actually working overnight during those days. And so I had trouble sleeping during the day. We don't have air conditioning in our house. I slept down in the basement, which was helpful. But, and, you know, on the one hand, like I know how to deal with heat illness. We all know how to deal with heat illness. And we know how to deal with a lot of sick people coming into the emergency department. So in that sense, we were okay, but we also struggled because we got overwhelmed on the third day of that event, which was the worst day. The South Seattle was hit harder than other parts of our region. And that's because there's more impervious surface, so more paved surface, less green space, It's just hotter. And there are more poorer people with less access to preventive resources there. And they got overwhelmed. They had a lot of heat stroke. EMS was able to keep up with the demand, but the hospital, Valley Medical Center, which is one of our 4 UW hospitals, and is the one down there, got overwhelmed. They ran out of ventilators. So they had people that lost control of their airways. They didn't have any way to keep them. So we at Harborview activated our regional disaster medical control center and started loading ventilators up on a truck to send down to them. And that helped. We also diverted all of that EMS traffic to other hospitals, which also helped. But UW Medical Center had laboratory breakdowns. Northwest Medical Center lost air conditioning. We had a number of power outages just east of the Cascades. We didn't have big ones here, but we were close. So we did okay, but it was close. I think another day would have been pretty catastrophic. And it was, I mean, it was already bad, but catastrophic, yeah.
Are there any exceptions to like the general rule that disease is becoming like more prevalent? Like, are there any diseases that are like increasing with climate change, any like full public health things?
Well, so yeah, there's actually been this long running debate whether, there'll be warming and more heat exposure, and that's bad, but there's actually then less cold exposure, and cold exposure is actually responsible for much more illness and death than heat is currently. And so it makes sense that you would have less cold exposure, you'd have less cold related disease, right? Again, as you might expect, it's more complicated than that cold related disease has to do with a lot of other things. It has to do with people going inside when it's cold, and respiratory diseases being more common and spread in close contact, and other things indoors. So it's, reasonable people have argued for a long time about this. The evidence that's emerging suggests, yes, we will see a drop in cold-related mortality, but it won't be proportional to the increase in heat-related mortality that we'll see, which is too bad. I mean, it would be nice to say, yeah, we'll see, we'll lose some more people when it's hot, but it'll be mild in the winter, and that will be good for health. And that will be true, but the net impact, particularly toward the end of the century, particularly in Asian cities, it looks like, will be a net increase in mortality associated with heat. But in some places, it will definitely get better. And I don't have the slides here, but there's some very interesting studies looking at the United States and what will happen in the United States. And in the northern United States, our growing seasons are going to lengthen. The weather will be milder. There are a lot of things that will be better. Seattle is the main port for things that, for activity that goes up into the Arctic. And I'm sure we'll see a lot more port business as a result of that. Probably Washington State will do better as a result of climate change than without it, economically. Even though we'll see health risks from it. Don't get me wrong, but it would be intellectually dishonest to say that we won't benefit in some ways from it. How long is this class?
It actually formally goes till 10 but I'm assuming you would go an hour. Or 15.
Okay. So next I wanted to talk a little bit about Working Group 2. And Working Group 2 is, of course, about impacts. And so interestingly, this is a figure from chapter 1 of the Working Group 2 report. And it shows how much in each pixel, how much evidence there is of climate change impact in a given place. And you can see pretty much the whole world's land masses, at least, we have quite a bit of information now about climate change impacts. I think there are about 80,000 studies arrayed here. And most of the impacts are adverse, not all of them, but most of them. And this is classic IPCC tons of information contained here. Plus minus, so plus means the impact is beneficial. Minus means the observed impact is adverse. This is different economic sectors. This is impacts on health and well-being from infectious disease, heat and malnutrition, which are not the same thing, but they're grouped here. Mental health, and then population displacement. And then the colors are the level of certainty. So dark colors, we have quite a bit of confidence in these findings, and light colors, we're not nearly as confident. So you kind of just get a general impression, oh, there are a lot of impacts and a lot of them are bad. And then you can kind of go through sector by sector if you're interested to do that. And one of the things that's different about this assessment report than others is that there really was an effort to try and tie things together in a way that, recognizing that climate change isn't the only thing going on in the world, that development is very important, and development is fueled largely by fossil fuel combustion. And development is actually very good for health. So you have this complicated set of relationships, but we also need very quickly as possible, to pivot toward climate resilient development pathways. So moving away from fossil fueled development, but also moving toward development that's more resilient to all of these hazards that we're going to be seeing more and more of. And there's still a contingent in the IPCC that very strongly says we can get to 1.5. It seems to me almost delusional to be saying that at this point. I don't get it. And people say, well, it could happen if there's an unprecedented effort in human history. So I guess it could happen, but it's very unlikely. That we really need to move quickly toward thinking about resilience in our development and in our activities, because the window for that is narrowing pretty quickly. That we still have pathways where we can build systems and societies that are resilient to climate shocks. But one of the challenges is every time you have one of these big events, and I'm not talking necessarily just like that heat wave we experienced was a big event, but it was short-lived and we didn't actually have any lasting infrastructure damage. Hurricane Harvey is a different story, right? It didn't maybe kill as many people, but the infrastructure impacts were really devastating, and the losses, the uninsured losses, are huge, and communities don't recover from those. If you don't have a ton of resources, reserves in the bank, and you get hit with those losses, you may never recover as a family, as an individual, as a community. And increasingly, without thinking about that, we're going down pathways where you keep getting hit by these losses, and it undermines your ability to move forward and invest in yourself. And it also exacerbates inequities. It pits people against one another. It pits the haves against the have-nots. It's kind of a vicious cycle sometimes. Another classic IPCC graphic. The take home for me of which is there actually is quite a bit of benefit from a development standpoint of activity that reduces greenhouse gas emissions and supports climate resilient development pathways. That this is where we say as a world we want to go. We have a way to get there. We just need to really invest in it more forthrightly than we have. Another thing that came out in this report, which I was glad to see, is that risk is now thought of in a much more complicated and appropriate way. That used to be, again, they sort of thought about climate risk as, okay, this heat hazard will get worse and that will lead to this. And it was a very kind of simplistic framing. Now we recognize that risk unfolds in different sectors, that you have interactions between the health sector and the food and agricultural sector and the energy sector. And then if you have impacts in energy, they're going to impact these other spaces too in very significant ways. And they may be amplified actually. And that these things happen in time. You have to think about the time dimension of these risks unfolding, and some of them are the connections are tight and the impacts cascade quickly. And in other cases, they're delayed by sometimes decades, but you still have to account for them. You have to think about them spatially. And a great example of this that's covered in the report is food systems. So we have, maybe 7 major food producing systems globally, but they're all very tightly connected through global markets, commodity markets related to food production. If you have a shock in 1 or 2 of those places, which is very easy to see happening with climate change, you have a bad year in terms of extreme events or drought, then prices go up very quickly and food producers start to retain their products instead of selling them, and prices go up really quickly. And so you get this cascading wave through the food and agricultural system, but then it has health impacts. And then people start moving because in some places they can't produce their crops anymore, et cetera. So, and then the other piece that was not really talked about before, but is now, is that our responses to these things can create other risks. And so California is another good example of this, where because PG&E, their electric company, was hit with billion-dollar lawsuits around the wildfires, they're like, fine, we'll just turn the power off when it's high risk, which they did. And people then don't have access to electricity for keeping their insulin cool and cooling their homes. And it's not good for health, but it was a response, and a logical one from their point of view, to the risk. But we're not, part of what's happening is these things are happening so fast that we can't keep up with it from a governance standpoint, which is worrisome because I think it's going to just accelerate. And some of this, it's going to be even more challenging to address these risks. So our chapter in the 7th, or in the 6th assessment report, chapter 7, it's the first, it was a new combination of things. It was health, it was well-being, it was the changing structure of communities, which is IPCC speak for conflict and migration. And it was the first, all those things used to be covered, but they were covered in separate parts of the report. And our goal was to put it all together, understanding determinants of health and other things. So it's appropriate, but the evidence is not out there that actually has synthesized these things. So we really struggled with this. While we thought it was a good idea, we couldn't find evidence that actually spoke to the question. We had quite a bit had happened since the last 5th assessment report. So there were several IPCC reports that we had to integrate. There were lots of new international agreements around disasters and migration and other things that were important. And then there are lots of actually really new methods in public health and global health that speak to this. So it was a very tall order. And these are some kind of janky figures because it's not gone through copy or proof, whatever they call it, when they make things look nice. But this is a visual guide to our chapter where we talk about risk. We use the standard IPCC framework. We talk about impacts, and you've heard a lot about those already. Projected future risks, and then looking at them across all of these different scenarios in the health sector in particular, and other sectors as appropriate, but also thinking a lot about governance and the role of governance and the possibility of governance failures in precipitating and worsening these risks. And thinking a lot about vulnerability, who's vulnerable and why. And this is a map of the distribution of vulnerability globally, and you can see it's pretty constant. We have vulnerable populations everywhere, but we have more vulnerable populations in certain parts of the world, particularly in sub-Saharan Africa and parts of South Asia. And those places also, in some cases, are going to be exposed to some really significant changes in climatic hazards. And so the risks in those populations are particularly important to pay attention to. So there were a number of key findings from our report, and I'm sorry for the text, but I thought it was probably the easiest way to convey these things. So basically, we're seeing increasing risk across all of these different dimensions in terms of health. And we are starting to see that climate-related exposures are a driver of migration. And that could be for economic choices, it could be from displacement from an event. And they're starting, in some cases, to contribute to violent conflict. They're not necessarily driving it, but they're exacerbating it when it's happening. And that's a new conclusion, that last one. People have worried about that for a while. Now we're seeing it. These are directly quoted from the report. So there is, in some ways, and Chris and I wrote a paper, mostly Chris wrote it several years ago, looking at the conclusions in each of the IPCC reports about health. And actually, the conclusions are pretty much the same from the very beginning. It's just that we've gotten more and more confident about them as we've gone forward. And this is a kind of an example of that. Like, we knew there were problems, now we can say with more certainty than we ever could. And there's greater evidence, particularly around mental health in this round than we had before. And we've also always said that if we have the resources, we can probably avoid a lot of this through proactive adaptation planning. But the resources are not being mobilized for this, unfortunately, or at least not in many places, and not in the United States. And climate resilient development, as I said, has strong potential to generate substantial co-benefits for health, well-being, development, et cetera, and reduce risks. But you have to be intentional about it. You have to fund that and support it. And there's this framing in the IPCC world of transformational change. It's like taking systems and really revising them so that they are appropriate to the challenges that we face, and also that we operate in sometimes pretty fundamentally different ways. It's a very tall order. And nevertheless, we call for transformation in several areas and highlight the benefits that those transformational changes would bring. Relying on indigenous knowledge to advance that. It's also a new piece of this that comes out in this report that wasn't there for others. And recognizing some new dimensions of vulnerability related to age and gender and other things that weren't highlighted as much. We also talk a lot about solutions, and I'm hoping I don't bump up too much against what Chris is going to talk about with you. She wrote most of the solutions part of our chapter, and she did a brilliant job. These are the main findings from that the need for sustainable development is more widely recognized, as I have said. The importance of health adaptation is more and more recognized. Whether it's being invested in is another story. We need more investments, and COVID-19 actually that pandemic highlighted a lot of this, and it highlighted the potential of what we can do if we set our minds to it. It also highlighted a number of the pitfalls that we face in trying to move very rapidly to do things in the name of health, and the societal friction that can result when you try and move very quickly to protect people in the name of health. We're still learning a lot about that, but it was very interesting to have that happen during writing this event, or writing this chapter. This goes without saying, moving towards low carbon societies has lots of health benefits. And most of those health benefits, if you like price them, actually pay for the cost of moving to lower carbon systems. But in a place like a country like ours, healthcare costs are not borne by the same people who bear the cost of doing the mitigation activity. And in a place like Britain, where they're both borne by the central government, you actually see a lot of investment in mitigation, and they reap the benefits in their health expenditures. And so they pay for themselves. We don't have that mentality here. And then what can we do about migration? Well, Robert will tell you much more about this when he speaks to you. And I think he'll be guarded about it, because the problems with migration are not quite as clear yet as some of the other problems. And they're also very amenable to governance solutions. And it's a question of, again, deciding to do the right thing and finding the political will. And there's been some examples of us doing that. And then there's some examples of us not doing that. And he'll speak more to that later in the quarter. And then similarly, there's some specific solutions related to conflict and peace that we can invest in more than we have up to now. And I'm not going to talk about this. This is a diagram that outlines climate resilient health systems. And if you have questions about that, I can bring it up. But otherwise, I think I'll stop. And you have a question back there?
Yeah, I had a question. Like you alluded to at one point about how the major conclusions from these various reports have maintained or remained somewhat the same, but confidence has increased. Do you think, at least for working here too, that the scope and paths of what we're supposed to do makes sense if the conclusions are largely repetitive and confidence just increases? Or do you think it still makes sense to put in this big international effort to have this report every 5 or 6 years?
As of right now, this is the last IPCC report that I'll be participating in.
Could you elaborate on that? Why that is the time?
Well, it is a huge amount of time. And I will say the first report that I participated in, I was really seminal for me intellectually. It really brought a lot of growth to me intellectually, and I'm grateful for that. This one was a little less so. This one was I kind of know a lot of this stuff, and it's just a huge amount of work to put it all together. And the opportunity cost of this was big for me. But also I feel like the mental model behind this is broken. People aren't paying attention to it really. And so this is partially me. I mean, I have had this conversation with other authors, and Chris, you should ask Chris the same question. She has a different answer. I've asked her. She will keep doing them. She wants to lead them. And that would be great. I'm not saying we shouldn't be doing them. I'm saying I don't think I'll be doing them, because I also feel like this report didn't talk enough about adaptation. And from my point of view, reading the tea leaves, that's what we've got left. And we better start learning and mobilizing to deal with it. And we're not really. And so that's where I'm going to put my energy. Sure. I'm sorry?
One more question.
Yeah.
I saw it on
Why don't we'll finish up with Jeremy. You can ask about that. Thank you, Jeremy. That was
Sure.
wonderful.